In this video, we're going to look at a particular type of rational equation and do some examples with proportions. So a few definitions to start, and again, feel free to pause the video if you need to copy these down. So one is a ratio. So a ratio is just the quotient of two quantities. So for instance, 2/5. So all fractions are one example of ratios. Sometimes you'll see it written with words, so 2/5 or as a colon 2/5. Now, in mathematics, we tend to use the fraction form the most. So you've actually been working with ratios for a long time, but maybe did not think of them as having as a vocab term. A rate is also a ratio, by the way. It's just that the units are different. So it's a special type of ratio where particularly the units are always different. So for instance, 55 miles per hour is 55 miles per 1 hour. So you still have that fraction or that, in this case, it's not a fraction, but a ratio idea, right? But your units are different, miles to hours, but it's the same sort of idea. Now, the last key piece here is proportion. So a proportion is a statement that two ratios are equal. For instance, we know that 1/2 and 4/8 are the same, right? 4/8 does simplify down to 1/2, or if we multiply both of these by 4/4, we would get 4/8. So a proportion is particularly when two ratios are the same. And that's really going to be our focus of this video here. So one way to solve proportions, although it's not the only way, is to use what's called cross multiplication or cross products you can hear as well. So notice here that I have one ratio and another ratio, and they are equal to each other. The key thing here is that with proportions, there's nothing else being added or subtracted in, right? So it's one ratio equals one ratio. This is a very particular case. Now, you could still do common denominators. So that's what we typically do for fraction problems is we use common denominators, we multiply and we cancel the fraction out. However, when you have a ratio equals a ratio, the easiest thing to do is to just multiply diagonally. And you actually get the same result. So you would multiply this way, and then you would multiply this way. So what you have here is you have 45 times 7 is equal to 5 times x, for instance. Now 45 times 7, you can do in your calculator, is 315. Here we have 5x. And then what typically happens is you have a nice simple equation. You're going to just divide by 5 on both sides. And what we get here, let's see, is 63. Now you could also do this by using the LCD. So in this case, the LCD would be a 7 and an x, so 7x. You would multiply both sides, or both terms here, by 7x. Now what happens here on the left is that the x's cancel, and on the right, the 7's cancel. Notice what you have left. You have 7 times 45, and you have x times 5. And if you multiply that out, you're going to see that you get the same exact equation as this step here. So the cross multiplying technique here, or also called cross products, you can also call it that. In either case, you're getting the same solution as using common denominators here, or the LCD to cancel. It's just that you're able to do it a little bit quicker. And again, but it only works for a ratio equals a ratio, which is why it's a very particular case. You do have to check your answer still, though. Let me remind you of that. So if you have x's in the denominator, just be really careful here, right? We can't be dividing by 0. And then you'd also want to plug this back in and just verify that it does work. So if we have 45 over 63, is that actually equal to 5 over 7? It is. If you divide these both, let's see, by 9 here, 45 divided by 9 is 5, and 63 divided by 9 is 7. So this does actually check out. These are usually pretty easy to check. We typically don't see a lot of extraneous solutions with proportions here, but it's not a bad habit just to verify that, again, it does work and nothing weird has happened along the way when multiplying. All right, let's do another example. So here we have a proportion, x minus 5 over 3 is equal to x plus 2 over 5. Notice that the left side is one term, right? Even though you have a minus here, it's all stuck at the same fraction. Same thing on the right side, you have an addition, but it's all stuck together. So I have a ratio equals a ratio, so I can use that cross multiplying technique here. So you multiply this way, and then you're going to multiply this way. So when I multiply this way, I have 5 times x minus 5. And this way I have 3 times x plus 2. You do want to be a little careful. You're going to have to distribute here as we multiply. So I have 5x minus 25. And here I have 3x plus 6. I can subtract the 3x to both sides. I can add the 25 to both sides. And then I can divide by 2. I'll let you do this one at home, but if you do this one, it does check out. Again, I would just probably convert this to a decimal if I'm being honest and use my calculator, right? Because I don't need to do a lot of work. I just need to verify that the left and the right side are equal. So you can plug this in and you can verify at home that this one also does work out. Now, in the next set of examples, we're going to do more application problems here. So applications are super helpful with proportions. There are a ton of proportion application examples. So we'll just do a handful of them so you can see some of them. So this says that many people still rent movies from about 33,000 red box locations. I know that the supermarket near me still has a red box, and they do have movie rentals right out of it. If renting 3 movies costs $4.50, how much should 5 movies cost? Now, this assumes that the pricing is consistent, right? That it's not changing, like there's no discounts for more rentals or late fees or things like that, right? So we're just kind of saying if the pricing stays the same, what would you expect 5 movies to cost? Now, there's different ways you can do this. You may be able to just figure out the answer kind of in your head if you're pretty good at seeing what's going on here. But a nice way to do it is to set up a proportion. So the way we do that is you need to have one ratio in completion. So meaning that, you have a pair of data that goes together. And here I know that 3 movies are $4.50. So I'm going to start by making that my first proportion. My first ratio in my proportion. Now, notice that I'm leaving the units in for now. And the reason I'm doing that is because I need to make sure when I set up my proportion that my units are consistent. So if I put movies on top, then movies has to go on top on the other side as well. If I put dollars on bottom, then dollars has to go on bottom on the other side as well. The question is, how much should 5 movies cost? So I know that we're going to rent 5 movies. So I'm going to match up, again, movies with movies, but I do not know my cost here. So I'm going to use an X for that. So our X is equal to the cost for 5 movies. All right, so key things here, you must have one ratio in its completion. So there has to be a pair of data that goes together. And as you're setting up your proportions, you have to watch your units. Units have to be consistent. So here, movies to movies, cost to cost. Once that's done, then you can go ahead and cross multiply to solve. So here I have 3 times x. On the other side, I have 5 times 450. Okay, let's see. If I do that on my calculator, I get 22.5. I'm going to divide both sides by 3. And I see that x is equal to 7.5. Now, remember that this was supposed to be dollars, right? X was our cost for 5 movies. So 5 movies, cost $7.50. Okay. Now we can check that as well. So how you can check proportions, another way you can do it. So I have 3 over 450 is equal to 5 over 750. So there's different ways you could check this. You actually could cross multiply and just check that as well. Or you could just figure out each side. So if I look at, for instance, my left side, 3 divided by 450, and the right side, using my calculator here, I do see that they're both the same. So this does actually check out on both accounts. I get this 0.66 idea on each side. So this does check out here. And again, this is just one way to do it. So other students may have recognized that, well, hey, if 3 movies cost $4.50, then 1 movie must cost $1.50, right? So you could have also done it that way and then multiplied that by 5. So different strategies, of course, here, but the goal was to just show you how to use proportions in this case. All right, let's do another example. So if the following 2 triangles are similar, find the unknown length. It says length, x. So first of all, similar triangles have the same shape, but are not necessarily the same size. But otherwise, they should look the same. Think of it almost like a nesting doll or something like that, where again, the shape stays consistent, but the sizes are changing along the way. If you remember any of your geometry, the angles are equal, so the corresponding angles would be the same. So for instance, like this angle here would match to this angle, and this angle here would match to this angle, and so on. So they'd have the same degree measurements. And then what happens is the lengths are proportionate. So we can use proportions here to help us figure out the answer. Now remember, like in the last case, you do need to have one ratio in its entirety. And you can see that right here, right? I do know both sides that are given of the first triangle. So I have 2 yards to 10 yards. And the second triangle, if you look, I only have one of the values, not the other. Now, the tricky thing here, though, is you have to match things up. So notice how the 2 yards was the shorter side. So on the top over here, I need to put the shorter side as well. So 3 yards. And then the X would go with the longer side, right? Longer side was here, longer side was here. So you do have to be consistent. You can't just put them in anywhere you want. So you need to find a way to match up the tops and the bottom. So here I'm using smaller sides versus longer sides. Once I have that, I can go ahead and cross multiply. So here I have 2x. Here I have 10 times 3. So I have 2x is equal to 30. I can divide both sides by 2, and I have x equals to 15. So it must mean that this side is 15, and my units there were yards. Now, I'll let you check this at home. Again, this does actually check out. You plug 15 back in here. You basically get 1/5 in each case, so the 2 sides are the same. Also, it does make sense. Notice that these are proportionate, right? So 2 is smaller than 3. It would make sense that 10 is smaller than this length as well, right? They should be consistent. So 15 does make sense there. So it seems like we are going in the correct direction. All right, I want to do one more example in this video, and then I do have a couple more I'll say for the next video. But let's do one more here. So this one is a word problem where we're finding out the number. And this one is actually a little bit different. So it says the quotient of a number in 6. So let's slow down for a second. So quotient means to divide, and order matters. So a number in 6, it must look like this. Minus 5/3 is, so equals, the quotient of the number in 2. So that would be x over 2 here. Now we're looking to find the number, so our goal here is pretty straightforward. You can write out the goal if you want to, but x is just equal to basically the number that we're trying to find, right? But let's be careful with our equation here. The quotient of a number in 6 minus, so subtract 5/3 is equal to the quotient of a number and 2. Now, this one is different. Because of this minus 5/3, I don't have a ratio equals a ratio now. I have a more normal looking fraction problem. So if it's more complicated like it is here, where you have this extra minus sign in a whole other term, we can't cross multiply this. So what you can do, there's different ways to solve it, but I would probably go back to my regular LCD method here. I see my denominators of 6, 3, and 2, so my LCD is 6. And then I would multiply all parts by that 6. So I just wanted to put this one in here because you do have to be careful that you can only cross multiply when it's just one ratio equals one ratio. Otherwise, you're going to need to find a different strategy to help you solve. So what I'm doing now is I'm just canceling out and dividing. 6 divided by 6 is 1. 6 divided by 3 is 2. 6 divided by 2 is 3. So in the first case, I have a 1 times x left, so just x. Here I have a 2 times 5, which is 10, and a 3 times x is 3x. I'm going to subtract x from both sides here, and then I'm going to divide it by 2. I'm going to get my answer is -5. So the number that we're looking for here is -5. Now, again, just to save some time, because we do have a lot of examples in this video, I'll let you try the check at home, and this one does actually check out as well. So if you plug in the -5 for x, and again, you can just use your calculator if you want to just make sure the two sides are the same. This one will check out.